Hello everyone, we are a research group named MANiAC from Kaunas University of Technology. Our topic for this research project is the effect of green roofs and facades on energy consumption for heating and cooling in office buildings. Before we go in depth with every part of our research, I would prefer quickly explaining how our research process looked. First of all, we defined our research problem. After it, we wrote down our three research objectives. From this point, we did a literature review and made three 3D models. And lastly, we combined all of the data and made a various simulations, which gave us results that were discussed and compared to numerical calculations that we did.
The increase of global population, growth of industries, and urbanization have caused a significant rise in the number of urban and especially office buildings. As a result, the demand for energy consumption necessary to maintain optimal conditions has also increased, causing the need for more energy efficient solutions in urban environments. An innovative method to reduce energy consumption for office buildings gaining popularity daily is green structures. Green structures represent vegetation applied to either horizontal, which is green roofs, or vertical, which is green walls, outer surface of the building. They balance thermal exchange and maintain inner temperature closer to the comfortable range, thus avoiding temperature peaks, minimizing losses, and reducing energy consumption. While the effects of green roofs and green walls on energy consumption reduction have been investigated individually, there is a lack of research comparing the two green structures. Besides, while previous research has been mainly focused on warmer regions, such as the Mediterranean and tropics, the effectiveness of green structures in the Baltic region and Northern Europe remain unexamined.
The aim of this research is to evaluate the energy efficiency of green roofs and green walls for cooling and heating through numerical calculations and simulations by comparing conventional A++ office building and buildings with green structures to determine which of the structures is more energy efficient for heating and cooling. The research objective is to define the terms of green roofs and green walls and specify what types of structures to be used in this research. Next, to review various studies on the impact of green structures and reduction for heating and cooling loads. The third one is to perform numerical simulations assessing the energy consumption of three types of office buildings for heating and cooling. To perform simulations and evaluate the impact of green roofs and green walls on heating and cooling loads, and then to conduct a comparative analysis to determine the influence of green structures on reducing buildings' heating and cooling loads. Step 1 of methodology. 18 scenarios were determined for heating and cooling based on three different sizes of buildings and building technology. Step number 2. Building energy demand was calculated based on different technologies, including A++, green walls, and green roofs. Number 3. Building energy consumption was modeled in IDA ice. And number 4, the results were compared to determine whether green walls or green roofs are more energy efficient for heating and cooling. The methodology outlined in the research shows a systematic and comprehensive approach to analyze the energy demand in modeled buildings for heating and cooling. The modeling and simulation process helps to understand the differences in energy demand calculations with consistency and accuracy throughout all 18 scenarios. The chosen research approach is mixed, including qualitative and quantitative methods, to ensure replicable results. This approach ensures that the current scientific research is reliable, systematic, and logical.
Research shows the most significant heating energy reduction with green walls occurred in an 11-story building, reducing heating demand by 1.61% and consumption by 4.06% compared to conventional design. Conversely, green roofs on one-story building reduced heating demand by 1.84% but increased energy consumption by 61.46%. For cooling, green walls on 4 and 11-story buildings reduced demand by 0.05%, though consumption in an 11-story building increased by 6.45%. Green roofs on one-story buildings showed that the largest cooling reduction was 0.011%, but resulted in an 86.09% rise in energy consumption. Overall, green walls proved most energy efficient for heating across all building types, consistently consuming less energy than conventional designs, while for cooling, none of the research designs had a significant effect.
Hello everyone, I'm here to share the key insights from our discussion and conclusion on energy efficiency of green walls and green roof in buildings. This study evaluated one-story, four-story, and 11-story buildings, focusing on Kaunas, Lithuania, a region with significant heating and cooling demands. External shading was excluded to focus the internal gains and envelope design. Building orientation had minimum impact on 11-story building, but it significantly influenced the one-story and four-story building due to their north-south exposure. Occupancy was considered based on the floor area, and evaporation in the green layer could further reduce energy consumption. Finally, the IDA proved reliable for simulations, though its accuracy depends on the parameters used. In our key results, green walls reduce heating energy demand with the 11-story building showing a 1.61% decrease and heating energy consumption dropping by 4.06%. However, cooling energy use increased slightly by 6.45%. Green roofs showed limited benefits, with heating demand decreasing slightly for one-story building by 1.84%. However, heating and cooling energy consumption significantly increased, highlighting their inefficiency. In conclusion, green walls are more effective solution for reducing heating energy demand and consumption, especially in larger buildings. In contrast, green roof proved inefficient, increasing energy use for both heating and cooling. Thank you.